Continuity equations problem solving. Problem number 1. If the velocity of a flow in a 75mm diameter fire hose is 0.5 meter per second, what is the velocity of the jet issuing from a 25mm diameter nozzle attached at the end of the hose? Compute also the power in watts available in the jet. So for this problem, you have to consider the two most important components for this problem to be solved, and that is the fire hose and the nozzle. So the fluid concerned is water which is flowing from the hose going out in the nozzle. So the fire hose diameter is given as 75 millimeters. The velocity of the fluid flowing from that fire hose is 0.5 meter per second. The nozzle has a diameter of 25 millimeters. The problem requires for you to find the issued velocity from the nozzle. Also, the power in watts due to the jet of water. As for the solution, by using the concepts of continuity flow equation or CFE, you will be given with this working equation. V1A1 is equal to V2A2. This working equation is formulated when equating the flow rate when the water flows from the fire hose to the nozzle. So it means all the components in the left side will be for the fire hose, while all the components in the right side will be for the nozzle. So V is symbolized by the velocity, while A is the area or the cross-sectional area where the fluid flows. So that goes both for the fire hose and the nozzle. You have to remember that V2, or the velocity of the fluid when passing through the nozzle, is what the problem requires for you to find. It may seem confusing that instead of using the diameter, we actually use this formula. So the area for the circle is actually pi over 4 multiplied by the square root of the diameter. So that will be given as 0.5 meter per second as the velocity in the fire hose multiplied by the area, which is given as pi over 4, 0.75 meter per second squared, equal to V2, the required for the problem, multiplied by pi over 4, 0.25 meter per second squared, thus giving you the velocity in the nozzle as V2 equals 4.5 meter per second. So the problem also requires for you to find the power of the nozzle, and it will be given as the specific weight of the fluid multiplied by the flow rate multiplied by the equivalent head. So remember that equivalent head is a measure of length. So since the flow rate and the equivalent head is not directly given, you must expand it as the flow rate will be given as area multiplied by the velocity, while the equivalent head will be given as the square root of the velocity divided by 2 multiplied by the gravitational acceleration. So when you substitute all this expansion to the working equation, you will be given with this. Specific weight multiplied by the area of the nozzle multiplied by the velocity in the nozzle multiplied by the velocity in the nozzle squared over 2g. So this will be the simplified version or the simplified working equation for this problem, thus giving you the power as 9.81 kilonewton per cubic meter as the specific weight of water, multiplied by the area given as pi over 4 multiplied by 0.25 meter squared, multiplied by the velocity of the nozzle as 4.5 meter per second cube, divided by 2 multiplied by the gravitational acceleration as 9.81 meter per second squared, thus giving you the power as 22.37 watts.